Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you'd like to support the channel, there is a super chat that runs alongside each of these shows while they are live. There's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show on Facebook and Twitter. And one last time, if you're new to the channel or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button to keep up to date with the Flat Earth Debate. Now, before I introduce our panel and Discord server, I'm going to say a quick shout out to all of the Nathan Oakley 1980 channel members, but in particular those on a level of Lion. So shout out to DJ Neo Shaman, Steve ALM, Anaconda Maltlicker 17, Rhett Priestley, Contrapian, hope I've said your name right, Windrider, and All People Free People. So big shout out to all of you for supporting me as a Lion Nathan Oakley 1980 channel member. We are joined by Righteous Force, Paul Hall, Chocolate Sane, and 10th Man in G+, together with a whole bunch of people in Discord. So welcome one and all. And Arwin.
Hello, hello.
Good morning, all.
Hello.
Hello.
Good morning. And I noticed I had a notification pop up.
Woohoo!
Show.
I just got it right now.
Hey. Getting notifications. Look at that chat speeding on by. Hey. We're actually reaching an audience. Thank God. Any signs of a physical Earth curve edge?
Not from Arcatilla.
I have a question on that.
Blocks and,
Can you hear me?
not from 2 blocks away from there.
Yeah, we do. Is that, hold on. Was that Moose Tone?
Nope.
Hold on.
Yeah, that's me. Can you hear me?
We hear you loud and clear. Go ahead, Moose Tone.
Okay. Yeah, I had a question about that because I'm wondering whether you remember I had at least attempted to make a small presentation regarding the bulge between 2 points, and I'm wondering because I was making some calculations in the Earth curve calculator, and it would seem that if you have I'm talking in meters, if you have 200 meters between 2 points at sea level, you would have a 784 meters bulge. So the sagitta. Did you follow me?
Yeah, you're just describing the general geometry asserted in the Earth curve
Yeah.
calculator. Feel free to carry on.
So if you were to be able to see a distance on sideways of 200 kilometers, then you would then it would be interesting if you were according to the globe Earth model, you would be able to see a 784 meters bulge, and I think the fact that you wouldn't see would disprove the globe, and it doesn't seem impossible to do that, at least geometrically, if I'm looking at it, because my understanding is that the observations to the Isle of Man, for example, were 100 kilometers, right? So if you're let's say you're at the base, at one angle of a triangle, if you're looking 100 kilometers in one way and then 100 kilometers the other way, then if you meet both ends, you might have approximately 200,000 kilometers. 200 kilometers between those 2 points. So perhaps you would be able to see that distance to observe that.
What's that?
Well, the bulge or the absence of bulge.
Yeah, that's what a black swan image is. What any black swan does. Shows the geometric horizon.
Yeah, but it does it.
Oh.
Yeah, but it does it in. I was thinking sideways.
Yeah, you're talking about the curvature on the x-axis, right?
No.
Are you not saying
on the other axis?
You're not saying that the horizon itself should bulge from left to right. Is that not what you're supposing?
Yes, exactly.
Yeah. I'm sure I mentioned this to you before. So in the same calculator, there's an advanced section. I think there's a little tab that gives you an advanced section, and it gives you the
It
measurements.
calculates the sagitta.
Yeah, but it still gives you the. Maybe I'm saying the wrong axis, but from left to right, you can calculate how many pixels it should be dropping by according to their maths.
Exactly.
It was.
But has anyone made an observation between 2 points on a flat plane, so sideways, that is far enough to be able to detect or not this famous bulge?
Well, as I say, the one
or to disprove it, let's say.
Well, yeah, the Isle of Man composite did, but because you're rotating the camera and then you're compositing together the image, that presents a whole raft of problems in and of itself. But ultimately, yeah, like you say, it shouldn't be too difficult, which is what agrees me when you have people like Neil deGrasse Tyson saying, well, you can't see it till 120,000 feet, you can't even see it. It's like, well, yeah, you should be able to calculate it from the ground. Here's the maths for it. One of your claims is Earth curve based on boats going over it, and that would result in, as you describe, your left to right horizon actually bowing and giving you a bulge. And it shouldn't be too difficult. It should be really obvious. You know what I mean?
Exactly. But I think what is especially strong here is that you can't argue refraction in that case, because you can't have refraction that's straightening up a bulge.
Oh, but they do. That was something else that came to head in the Isle of Man discussion. So when Chris Monk's modelling all this out, and I'm explaining to him that as we're looking down the length of the Isle of Man, just see if I can find this so I can actually have it on screen while I'm talking about it. So as we're looking down the length of the Isle of Man, what we're seeing is further and further and further and further beyond the Earth curvature, and obviously that's just a fixed point at a given distance on the line that they used to claim was a geometric horizon. Well, I'll just play it from here. Hopefully we'll see some of the clips. So that being the case, for things to be on the horizon when they're further and further around the curve, they've got to be more and more refracted, more and more lifted up. And eventually I posed the question, well, doesn't that mean that everything is refracted? And the answer is yes. You can find citations, I haven't got any to hand for this, but yes, absolutely. Everything is all refracted. The whole lot. The whole thing's a mirage. Literally. In their model. It's absolutely nuts. But nothing's where it's supposed to be. In their model. In physicality terms, nothing's where it's supposed to be. It's all been bent up and refracted up into the position that it is that you see it. And that's particularly easy to explain when you've got the Isle of Man, because it is like a little... what would you call it? Like an almond shape. You're looking at the tip, and then you're looking further and further and further and further down the island at greater and greater and greater distances. God damn it, why can't I find it?
So would they also be saying that...
Sorry, I've just found it.
Something flat on the horizon,
Sorry,
and then refraction is... it's curved sideways, so from left to right, but actually refraction is flattening it out? Is that what they're saying? Really?
Yeah, it's bringing you all more and more back from beyond the curve, if you want to phrase it in a particular way. But what I've got now is the model I was just describing. So, you've got this tip here is where the Mackord lighthouse is, and obviously if you represented this as the image that we've got, albeit with an arc, because the camera's taking an arc. Rewind it. I think it's actually got that in this picture with the... There we go. So this is the composite image, and it starts here, ends here, and it's arced around. And this is our position at St. Bees, and we're looking through the viewfinder. Our closest point is 31 miles away, and that's Mackord Lighthouse. So what you've got in terms of the picture that it presents you with is obviously just a single line horizon. But what you're actually looking at is further and further and further and further away as you look down the image. And there's various mountains that are dotted that, again, are going further and further beyond the curve. But for each individual one, you'll calculate it with its refractive value and how much it's been brought up. But obviously that for this mountain here is going to be different for this coastline here because it's a different position on a spherical surface as it curves around it. So in simplest terms, everything is refracted and nothing's where it's supposed to be. It's all been bent back up from furthering distances beyond the claim to be geometric horizon, obviously now debunked. So yeah, the whole thing is a nonsense. But you can only really discover those things when you start modelling it out and going through the process of describing how their models work by modelling it yourself. Now, at the time, we were all for the idea of reifying models. Some wanker got hold of a clip from that from about 4 years ago and juxtaposed me recently saying, we don't live on a model, with me back in the day saying, here's a picture of a model, we live on this bit here. It's like, yeah, what, 4 years ago when we were all reifying models together happily? Well done, yeah. Yeah, now I realise we don't live on a model. What do you know? People change their minds. You know what I mean? I didn't know what a reification fallacy was then. Anyway, my point being, this model is all refracted in their terms, and everything is in a position that the photograph presents, which isn't a position in geographic terms when you wrap it around a ball.
Oh, Nathan.
So yeah, but I don't get the argument on the side view, but because I mean, if I'm seeing something flat on the horizon that why would that? So essentially, it's curved from left to right, but refraction is making it flat. Really?
Yeah, it's doublespeak. Yeah, it makes no sense. It's a complete contradiction. But yes, that's right. That is their contradiction.
It's even sillier.
Has
than
that really
It's
been
not only
claimed?
that
Like that. I mean,
Hold on, Chocolate.
curved, but
Hold on,
refraction
Chocolate. Hold on. Go on, I just want to hear this guy's revelation to the total doublespeak that is the model. Go on, go ahead.
No. But I haven't heard it claimed explicitly in that way by any glober. Really explicitly, because they're always talking about refraction, so lifting things up from behind. But I haven't heard about them really claiming refraction is unbending things sideways.
Well, no, because they say that it's bending it to appear straight. So while it might look and calculate as being completely flat, what's actually happening, it is wrapped around a sphere, but I presuppose that item that appears to be flat in our picture is actually bent from beyond a reified Earth curve edge into a position where it sits on the horizon, refracted into that position. That's what they tell you. I mean, obviously they don't explicitly say, yeah, what we're looking at is basically the appearance of a flat world with perspective, but I don't account for perspective. I put it in side view and I mathematically calculate how much it's behind the reified Earth curve edge, and if it's further away, it's further behind that edge, and I'll just bring it back more with refraction because it's further away and I've got more refraction to bring it back with. That's not how they're going to say it, though, is it? They just say refraction. That's all they say.
Yeah, but sorry, just to clarify, really, if I'm understanding correctly. So you have point A on your, so really on the horizon, you have point A on your so on your left, and you have point B on on your right, and you have a straight line between the two. Really, it's and you're seeing something straight, and they're saying no, this. Are they really saying this is curved, but because of refraction, you're seeing it straight?
Yes. I've said this twice. I
was
waiting for your...
I've never heard that claim.
That is what they are saying.
Never heard that claim.
I know you haven't heard them say it explicitly, but we're talking about a model that makes no sense in reality and how they double speak their way around it. So no, they're not going to give us these explicit disclaimers. We have to drag them by their short hairs, point it out to... Mate, please. We have to drag them by their short hairs, pointing it out to them. But that's what we do here. Thumbs up.
Yeah. Okay. No. That's fine. So,
Yeah, man.
so Neil deGrasse
the
Tyson
thing.
is saying
They're not
when he
going
says
to
it's
come
flat.
out and just tell you these things, right? Because they have a narrative that they're trying to push. So they tell you these things in a way that you can accept it, right? But that's not the case, right?
No, I know.
It really isn't. Yeah,
I know. I'd be interested. Sorry.
No, no.
Look,
I
I'd
mean,
be
it's
interested
cool.
in
It's
doing
just-
modus tollens on that one, to be honest.
Well, I mean, they've
I can help
already
ya.
denied the geometry of their model because before the black swan, they used to say that the geometric horizon was a thing, right? They used to call it the curve, the physical location that boats would go over that would obscure objects. Well, now they don't have it. Not only do they not have it, they say we've never seen it. So then how do they measure something they've never seen if everything is refracted?
They
It's a done
calculated.
deal.
They calculated
Yeah, it's not measurement.
based on their model.
So yeah, I just had just a second question on that. So is there anything else? So beyond there are pictures from space, and this supposed boats going over. Are there any other? What are the other? What is their other cowbell? What is their other observations? Of
You mean what
curvature?
else they got? Nothing. That's it. We've debunked the model.
Yeah,
That's it.
pretty much
You've got pictures from space to prove it's a ball. Well, they're been debunked by natural law, second law of thermodynamics, Boyle's law, gas law. We take your pick. It doesn't conform with natural law. So space, pictures from space, all fake. What you got then left over? Well, you got your observations from the ground with the mathematics of geometry. That's it. Once you debunk R, by debunking the geometry, the presupposition of this R value giving you a geometric horizon to begin with, once that's gone, everything about the model falls in upon itself. Now, it's taking some time for the fundies to realise this. Some of them just stick their heads in the sand and go, "Dead swan, it's already been debunked." Really? Okay, explain how it's been debunked. Because the modus tollens is absolutely watertight and it basically destroys your R value. You no longer have a presuppositional R value that's justifiable, giving you a physical geometric Earth curve edge. So it is game over for the model, and I think that's what you're asking. What else they got? Nothing. They've got a dead model.
So if you were to bring back Al-Biruni, so I mean, by the way, I don't know if Al-Biruni removed the atmosphere, but Al-Biruni would come and you would actually measure
like
the Earth to be the size, bigger than Jupiter, right?
Not exactly. So if you use Al-Biruni's measurement on the black swan, the original black swan, there's been loads, but just we like to focus on the original and best. Well, yeah, you'd end up with the outer edge of the Earth, i.e. if you just take one point as their edge, in this case we'll take the equator. The equator, in terms of its physical size, would be the same size as the orbital path of the moon. So your R value becomes the distance to the moon.
Just a little bigger. 260.
Yeah, it is actually a little bit bigger. That's right. It's actually beyond that. But yeah, I like for people to reference it. If anybody's got any idea of how far the moon is, if you've seen it done as a scale demonstration, if you haven't, go and check it out. Just type in scale demonstration of the moon and how far it is from the Earth, and you'll find somebody on YouTube with a golf ball and a football or something similar, showing you how many paces away you have to be to get that scale for the claimed orbital distance based on Kepler's third law and an assumption of the R value. Nevertheless, if you can see that, it gives you an idea of how big Earth would have to be the size it should be if you've still got a physical geometric horizon. The reason it's called the Black Swan is because it smashes it so far into next week that even their own side have to relinquish the idea of having a geometric horizon. And at that point, it's game over for the globe.
Yeah.
After Arwin comments, I'd like to make a comment.
Well, I was Moose Tone. Was there anything else you wanted to add to that? It's your point.
No, not really. I mean, no. I think it's pretty revealing. To be honest, I just yeah. Again, I think should the argument not be, well, look, if there were, if you had someone, let's say from the Middle Ages or from earlier on coming in, how would you show that person that there's curvature?
You can't utilise the model to show them anymore. So, well, just to answer you, so what you would have done is gone and got a fake picture from a fake place and said, here it is, we've already taken pictures. Not me personally. Liars who claim they go to a violation of a natural law have taken pictures. Well, they're in a natural law violation. They definitely haven't taken any pictures. That's a big fat lie. one of the few people in this argument we can actually directly call liars, because they are. They know they're not going to a sky vacuum because there isn't one. That's a violation of natural law. Anyway, once you get to the ground level argument, all you've got to assert is a presupposition of an R value giving you a physical geometric horizon. That's the starting basis. So before 2020, before the Black Swan argument, you could justify, if you're a fundy, to your own satisfaction, that it's okay and acceptable to presuppose the R value. Now, all we could do is say, well, you're a fundy religitard then. In R you trust. Radius dominus, gravitas spiritus sanctus. Go in peace, fundy. You trust in R. Well, now they can't trust in R because the model's become untenable. You don't have a physical geometric horizon. You don't have what the R value gave you in the model. Now you only have a geometric horizon existing in one place only in existence in the model. Therefore, not our reality. And a justification that, well, it's not the geometric horizon, it's a refracted non-geometric. Well, that's not the model then, is it? The game over, globe. Nowhere to go. It's the end of the road. It's become untenable. You can't trust in R. R's been debunked. The geometric horizon, by their own standards, is no longer geometric. It's no longer physical Earth curve. So what they got? Nothing. The end of the globe religion. It is untenable.
Yeah.
First housekeeping question.
Yeah. I think they have nothing else. So, well, thank you very much, guys. Very interesting.
No
Isn't
problem.
it just? That's why it's so quiet. And what are they going to rebut it with? You know, other than a few stragglers that come along with older arguments they don't understand themselves. You know, I'm searching for responses at the moment, and it's really scraping the bottom of the barrel. Generally, people were like, oh, it's already been debunked. Here's another picture of a white swan. And then you look at it and go, that's a black swan. They obviously don't understand the argument. But, you know, these are, like I say, the tail ends of anybody with any modicum of intelligence actually attacking this argument. And even those people with what they claim to be massive levels of intelligence basically affirmed our argument and said they don't have a geometric horizon, and then drew some donkey dicks on some spheres. It was really funny.
And then said you would never expect to see the geometric horizon.
Yeah,
That's
indeed.
great.
Go
You
ahead,
would never
Moostone.
expect to see the curve, guys. Don't worry about what we've been arguing with you about for all these years. Nah.
Exactly. We're not going to expect to see that curve right on chocolate. Go ahead, Moostone.
Yeah, no, I mean, I haven't heard anybody ask whether Al-Biruni had removed the atmosphere. But has anyone asked that question to a glober?
We don't need to. We can make the assertion on our own. So, you know, we brought up Al-Biruni of recent times for that very reason. All right, so it's always refracted. All right, well, that buggers up the claim from Al-Biruni then, doesn't it? You know, that's just make it as a statement. Don't need to ask them anything. What, you're going to ask him? You could say, given that you believe, Fundy, that the sky is a vacuum and you live on a globe, did Al-Biruni manage to get those rebellious gas particles who were burning their bras at the Kármán line saying, no, we won't obey natural law? Did he temporarily get them to all disappear into the sky vacuum as per natural law so he could see the geometric horizon to make this original presupposition and measurement of a horizon dip? Or was he dealing with high levels of refraction, given that he's going through all those layers you use as a red herring straw man when describing a gas pressure gradient? Well, that would give him a whole bunch of refraction, wouldn't it, from up on that mountain? So he's definitely going to be dealing with some refraction then. Oh dear, origin story for the R value. Bye-bye also. So you don't need to ask them anything, just shove it right in their face that their origin story also dies along with their R value and their geometric horizon and their assertion that they live on a sphere. All dead.
Did you just call the first gas molecules feminists?
Owen, this guy's responding to what I've just said. Go ahead, Moostone.
Yeah, the thing is, but who then calculated it in the first place if it's not Al-Biruni? I mean, someone
it's Al-Biruni.
Been able to calculate this without any atmosphere. And if not, then, you know, this is just completely bunk.
It was Al-Biruni.
But there was atmosphere, was there not? So I mean, this is
was there even an Al-Biruni? Who knows? Who cares? What we're told is a dude called Al-Biruni, who for the narrative purposes is a guy standing on a mountain, and measured it with a shitload of refraction, because everything's refracted, and they're going through all these different layers of atmosphere from up on a high mountain, because obviously we've got gas pressure gradients, and for a gas pressure gradient, you've first got to have gas pressure, and for gas pressure, you've got to have a container. But all that being said, there's definitely a gradient going up to that mountain. Definitely refracted then. Bye-bye, origin story. Does not compute.
Yeah, but that means, show it to me, I think they should be able to show it if it's there. They should be able to to do Al-Biruni's observation once again.
Again,
and they should be able to do it all the time.
What's it? Be specific. Hold on. What's it? The geometric horizon. They should show it. No, they hand wave you and tell you we don't see it. That's what they'll tell you in defense. When you say, well, you should be able to see it, it being the geometric horizon.
Someone must have calculated it in the first place, Nathan.
Yeah, he'd need to see it, wouldn't he?
Yeah.
That's the beauty of this argument, brother. There's nowhere for them to go.
Yeah, but what
it's so simple. I mean,
hold on, Moostone. Hold on. Go ahead, Arwin.
How come they?
Hold on 1 second, Moostone. Hold on.
When you have a globe,
hold on.
To ask
Hello. Hold on, just 1 second. There's 3 people that want to respond to you. You've got 10th Man, Chocolate, and Arwin all wanting to respond. Who wants to go first?
Oh, okay, sorry. Go ahead.
No, I just had a joke. I've had several. One was when you talked about that wanker that brought up a photo of the Isle of Man bulge, and I just thought that was kind of funny. The second one, and gay, by the way. And the second one was, I don't know, I even forgot what I said. I know nothing.
Got to work on that comedic timing.
It doesn't work if I don't interrupt. See? You can't make me wait for 5 minutes and say it after.
My God.
It doesn't work.
All right, go ahead, Temp Man.
that was
Right.
good timing there.
We'll work on flattening the Isle of Man curve later. Right,
All right,
Chocolate.
So, I'll
Chocolate.
go next.
Oh, okay. Go ahead, 10th Man.
Yeah. All right. So to Moustone, that Al-Biruni test, or whatever you want to call, has been done by Neil deGrasse Tyson. He went up 128,000 feet and said everything is refracted straight.
Yeah, he should have.
No, did he say that? Really?
Yeah, he said you can't see a curve from 120,000 feet. Yeah, man, you need to let Al-Biruni know that, NDT.
No. But did he say it? Did he say it's refracted? It's straight. It refracts to become straight. Did he really say that explicitly?
No, Neil deGrasse Tyson.
He said it looks flat, but
yeah, he said that stuff looks
but how
flat.
could it look flat?
His exact quote was that stuff looks flat, and he's just basically saying when he's got a beach ball in his hand. In other words, he's saying Earth is a sphere. Now, the beach ball implies that he's talking about the geometric sphere edge that you would see if you were an ant hovering a millimetre above the beach ball. In other words, he's absolutely, explicitly describing a geometric horizon, the edge of the beach ball, when he says that if you go up on the Earth's equivalent, because Earth's obviously the same as this beach ball, sphere-shaped, and physically going to have obstructions that are Earth curve geometric horizons, and you won't see that being a geometric bent horizon at 120,000 feet. That stuff is flat. That's his quote.
You can't see the curvature of the Earth from 2 millimeters above this beach ball. That stuff is flat.
There you go. Chocolate's great with quotes.
So how does a curved surface look flat according to Ballers? Refraction. So Al-Biruni sees it at the top of the mountain, and Neil deGrasse says, no, I'm going to throw you under the bus. Earth is really big. Even at 128,000 feet, you can't see it.
Maybe that's what we'll end up with. Maybe there'll be a paradigm change and we'll end up with an Earth that's actually gimongous. Who knows? I don't see how they can. Ours is supposed to be set in stone. It's based around celestial observations. The presupposition of Venus being the same size. All of this stuff is based around Earth with its fixed R value. As I say, set in metaphorical terms because we don't live on a sphere, but in actual terms in their model, it would be set in physical stone. Their model is saying that Earth is a stone that's a sphere. Therefore, you're not going to be changing an R value at any time. And, you know, the reason they've got to that first conclusion is because of the celestial observations.
But are you absolutely sure that they don't have, like, the mathematical maneuvering room to make it slightly bigger? They did back in the day even changed the distances to the sun and all that pretty arbitrarily. So
Yeah.
why would the model not have that flexibility anymore? I know it doesn't make any logical sense, of course, but
Well, let me
now
I
answer.
can answer.
Let me
I
answer.
can answer that.
Let me just answer. You can do whatever the hell you like in a model. What I'm saying is, if you're to transpose the model onto our reality, then the model's dictating a fixed rock with a R value that's sphere-shaped. Well, that fixed rock can't grow and shrink. It's a physical fixed rock if you're reifying the model. Now, as soon as you change the R value, you're saying, well, we've got it wrong. It's not a physical rock of that shape or size. Now, if you're going to use the same method, you end up with the black swan giving you a massive, ginormous, enormous sphere, right? Well, in the model, you can just change it because we don't live on a model.
Isn't one of their stories that you could actually fit all the planets in the solar system in between the distance between the Earth and the Moon? Isn't that one of their stories?
I don't know.
Here, I could give it a quick comedic answer to the whole thing. If they're going to do that and say that the size of the Earth has been bigger, we got it wrong, then every airline would have to raise their frequent flyer miles and they'd go broke.
Moose Tone, anything more to add?
Wow, so deep, no one got it.
Sorry. Yeah, I mean, one last thing. Maybe just a suggestion. Maybe someone should do modus tollens on these balloon sightings that are very, very high to see if, maybe there's a way to disprove. So, I mean, with using modus tollens to show that the absence of curvature disproves the globe from that perspective as well. Just an idea.
Okay.
Can I add a bit of geometric cowbell for you?
Go ahead.
While we're talking about this, because the R value works upwards, doesn't it, Moose Tone? So if we work from what we know and what we can see geometrically, then the horizon is said to be parallel with horizontal, or horizontal's parallel to the horizon, and vertical would be perpendicular to that, or independently. Both of them are independent of each other, but they are said to be perpendicular. Strictly.
Okay.
So there's no curve because their geometry's gone. I mean, they'll admit that. So the only geometry we actually have is the geometry that we have of vertical and horizontal. Ours disappeared. And seeing as the water level is defined as being horizontal, even the tool, the word level means horizontal. I'd say they're struggling for a curve. Will that be right, Moose?
Yeah. Yeah, definitely.
Just to summarize
There's
that
the
point,
problem.
excellent point, Bev. Just want to summarize that. So you're saying the R value's dead, and given that the R value was inserted into this geometry, and once it's dead, then no justification for inserting it. So what you're left with? Well, you're left with planar geometry. That's it.
Well, Euclidean geometry, yeah.
Or Euclidean.
Yeah.
Just for some cowbell on my own question that I asked before. Yes, you can, based on the distances, you could fit all the planets in between the Earth and the Moon with room to spare for maybe another Jupiter and maybe another little dwarf planet. So if the numbers of the black swan show globe, then your globe is that big. Radius 264,000 miles. It's ridiculous. Might have to
best.
change your story then. A little bit.
Well, flattening
At best.
flattening the curve would mean, you've still got a curve, but it's just a much bigger ball, right?
Did someone say at best?
At best.
At best?
Yeah, I said that. At best, yeah.
Yep. At best, what you've done is prove us wrong. That's basically what they say. Yep.
Well, that was a solid half an hour on one housekeeping question. Anything more, Moostone?
Okay, thanks, guys.
Excellent input. Love it. Any signs?
My pleasure.
Any signs of? No, it was a good. I love it. Doing half an hour on one question is good. Excellent. Any signs of axial rotation?
No.
No.
So are we talking about, is this where we speak about Coriolis?
They use the Coriolis effect as a claim that Earth spins.
Okay. Yeah, well, sorry to
But then they
bother
go.
with that.
But then they go out.
Sorry, I had a question on that.
Go ahead.
Perhaps regarding the how do you call that? Not the merry-go-round, the roundabout. Yeah. So it's just something that I noticed in debates you had with Zanuck, perhaps, regarding the example of someone on a roundabout having a drone, and then so letting go of the drone that then goes up and leaves the rotating reference frame, the non-inertial rotating reference frame. And there's just one point that's not always qualified in those examples. Is, to me, it does make a difference, although in both cases you do see Coriolis effect, in my opinion. Let's take the first example. First example is you have someone on a roundabout, and then you have someone that is outside the roundabout with a drone, and the person outside the roundabout, makes the drone go up, and from the perspective of the person on the roundabout, there is a Coriolis effect, right? You follow me?
So far, so good.
Now, second example is when the person, the drone is held by the person on the roundabout, and so that person at some point lets go of the drone, and the drone goes up, and the person on the roundabout also experiences Coriolis effect in his observation of the drone going up. Okay,
yeah, that's the same example.
Now,
the only difference is there's a
yes.
person watching it with the first example, but other than that, they're exactly
Yeah,
the
but
same
wait.
example.
Let me come to my point. I think there should still be a slight difference. Is that, and this maybe goes into some of the things that the ballers are saying, is that in the second example, there should be at least a limited inertia, a rotating inertia of the drone, because it's been held in the hand of the person on the roundabout, and then when he lets it go, it does go up, but it still has a slight rotating inertia. Do you agree with that?
Well, the same is true in both examples. So if you've got a drone that's in front of the guy, as in the first example, and then the guy off the roundabout pushes the up stick, well, yeah, it's still rotating whilst attached to the rotating roundabout when it first goes up. So for a fraction of a second, yeah, it's going to have some forward momentum from the roundabout. But obviously, once it's left the roundabout, it loses any momentum that it had because it's no longer attached to the reference frame. Same principle applies if the guy's holding it. He's holding it and it's going around and around with the drone hovering but being held, so it's still attached. As soon as he lets go, well, for the fraction of a second that it was being pushed forward and he's let it go, it is still semi-attached, if you want to call that. But once it's no longer attached, it's no longer going to retain any momentum. It's not attached to it. So the same is true in both examples.
I'm not sure, because, or maybe I didn't explain my first example. In my first example, the person holding the drone is the person outside the roundabout.
Right. Oh, I see. Well,
So-
yeah. Okay, sorry. Yeah, I didn't appreciate that. So,
rotating
yeah, I
movement,
get you.
right?
I get you. The guy's standing on the edge of the roundabout, and well, for that guy holding the drone, let's say he stood right next to the roundabout, and there's another guy on it. Well, the
Yes.
guy's still experiencing Coriolis effect just by looking at the guy, because the guy seems to be moving,
Exactly.
doesn't he? Well, you don't even need to let the drone go up in the air for him to see and observe a perceived deviation. The guy seems like he's coming towards him and going away from him on the edge of the roundabout without any drone needed, because he's not on the spinning reference frame. He's in the inertial reference frame just by standing on the edge of the roundabout.
Yes, I'm trying to make the examples as close as possible to limit the amount of variables, but you see what I mean? The point is that it seems to me in the second example where the drone is held by the person on the roundabout, as I said, there is, as you alluded to earlier, there is a slight inertia. And so I think the ballers are using that to sort of claim that it stays stuck to the things,
I know.
Things that cling to the earth, etc.
Yes, I get it. The conservation of angular momentum. Yes, they use that as a defense. But what you're asserting,
exactly.
Just let me explain why it falls apart. If you were to assert that the drone, when it lifts off the roundabout, essentially conserves the momentum of the roundabout. In other words, even though it's left it, it's still hovering above the same exact point on the roundabout. So before you stick your drone on the roundabout and spin it, you put a little piece of tape on there and an X mark on where you're going to put the drone before it takes off. Then you spin the roundabout, so it's sat on top of the tape, not hovering, attached to the roundabout. You push your up stick, but because of the conservation of angular momentum, it still hovers above the same X and rotates with the roundabout, even though it's not attached. It's conserved the momentum. But then you don't get any Coriolis deviation. It's in defiance of the actual Coriolis effect. The whole point of the effect is you see it deviate because you continue to rotate underneath. And it doesn't. The drone doesn't rotate. It just goes straight up. But because you carry on rotating, you see it seem to deviate. But if it's conserving momentum, you're not going to observe any Coriolis effect. So celebrity wanker number 1, Simon Dan, shows us a trampoline towed by a tractor. And the guy's bouncing, but he goes back down to the same point on the trampoline, like there's an X on it, like in my example with the roundabout. In other words, the guy bouncing does not deviate. Well, then there's no Coriolis deviation. The bloody thing's supposed to be proving Earth spins by showing us things do deviate. They get around it because there isn't any by saying, well, we shouldn't see any deviation. It conserves momentum, flying in the face of their very claim that we've got a proof that Earth spins in the form of the deviation that we see, not the lack thereof, as Simon Dan showed us with his example of a trampoline towed by a tractor. No deviation, says Simon Dan. Well, no proof of the Earth spin then, Simon Dan, you complete clown. But that's their get out, yeah. Oh, well, we shouldn't have a deviation. Well, isn't that the thing that's supposed to prove it spins?
Yeah, I think that's what they use to say that it doesn't leave the spinning reference frame.
Then there is no Coriolis effect. The thing that they use to prove it is spinning?
Yeah, I know. But remember what Zanek's defense was? Well, actually, if you put an observer outside, which I'm curious to see if they have any evidence of that. But
that's not Coriolis.
Actually,
the inertial reference frame
observer outside of the Earth to see, and then you would see.
Yeah, that's not. Then you would leave okay, I get it. He's saying put an observer outside in space. Yeah, that isn't Coriolis effect. Coriolis effect is then beyond the limits of the definition of Coriolis effect. That's not how Coriolis effect is defined. It's very simplistic. Inertial reference frame, non-inertial reference frame, which you will remain on as it spins. Things that are not attached to the spinning reference frame, also known as a non-inertial reference frame, will observe an apparent deviation because they continue to rotate underneath. That's Coriolis effect. Nothing to do with being in space. Utter nonsense. He's never going to find a citation or definition that defines it that way, that isn't utilising a fundamentalist globehead religious assertion that we're on a spinning ball to begin with and begging the question thereof. So ultimately speaking, Coriolis effect is very simplistic to explain. Roundabout spins, you throw a ball up, or in this example that we've used, you push up stick on a drone, it leaves the spinning roundabout, and because you continue to spin underneath, you see an apparent deviation. Well, that's not going to space and seeing things spin underneath you. That's not Coriolis effect. Coriolis effect is only achieved by you observing something that seems to deviate because you're spinning on a non-inertial spinning reference frame. So you've got idiots out there at the moment that have gone back to 2015 arguments and they show you things like winds and water turning. And you go, hello, Coriolis effect is an apparent deviation. Or to put it another way, a ball travels straight, but because you spin underneath it, it seems to be curving. It isn't, it's going straight. So just to be clear, the ball is going straight. So it's not a spin direction for hurricanes or a spin direction for water going down drains. Those are actual spin directions. Coriolis effect is an apparent deviation. Apparent meaning not actual. Ball travels straight but seems to curve. So all of the morons out there that use winds actually turning and water actually turning as though it's Coriolis effect just demonstrates they haven't got the vaguest clue what Coriolis effect is.
Yeah, you could.
Can I just add something to
Hold on, Moose. Go ahead, Chocolate. Hold on. Go ahead, Chocolate.
No, I was gonna say you could literally call it an illusion, right? Because it's a parent deviation. It's not actually deviating.
Yeah, it's not
Literally an illusion. So how can an illusion be the cause of a wind storm that's actually rotating like a hurricane?
It isn't. It's a misunderstanding by
I just wanted to just wanted to go back to this what Zanuck was saying, because he seemed to say that you would need something that's outside the spinning reference frame, and to him everything that's on Earth is in the same reference frame. So essentially, to show Coriolis, he would need to have something that is outside of supposed spinning Earth. And, for example, I don't know, being on a spaceship and shooting a bullet or some projectile.
Sorry, I've got to stop you again.
In a straight line.
Sorry, I'm really sorry.
We would see the Coriolis.
I just need to stop you again. I'm really sorry. That is not Coriolis effect, regardless of what Zanuck wants to describe it as. I've just gone through this. So going through his detailed explanation of what he wants Coriolis effect to be is meaningless. Coriolis effect requires you to be on a spinning reference frame and observe something that's not on the spinning reference frame. That is Coriolis. Not Zanuck's fantasy idea of Earth not having Coriolis because it's all the same reference frame, because he's flying in the face of Neil deGrasse Tyson. Ball gets kicked on a playing field. From the stands, it seems to deviate, curve into the goal. But it's really travelled straight, Earth span underneath, while you were all attached to it, watching the ball seem to curve. That's what Coriolis effect is. Going out to space to see the single reference frame Fantasy Boy Zanuck has got us as, with a presupposed spinning Earth, and Earth being bonded to its air, defying gas law and the nature of air, is a nonsense. We don't need to dice this up endlessly. I know Zanuck thinks you need to go out to outer space to see Coriolis, because he's got the whole thing as one reference frame. Well, that's nonsense. Can
I just specify what I mean? Because maybe I wasn't clear. I'm the observer. I'm on the spinning Earth, the supposed spinning Earth, and then someone else, just as in our roundabout example, is someone is outside of Earth, really in space, and shooting a projectile in a straight line, and then the observer on this supposed spinning Earth would see a rotation, whereas the projectile is going in a straight line, and that would be Coriolis.
Yeah, I understand. You're saying that if you've got the Fantasy Boy Zanuck's single reference frame of Earth and atmosphere as one, the only feasible way to see the actual effect of Coriolis deviation, that would be something that travels in a straight line outside the single reference frame he's fantasized Earth and air are. They would have to have somebody out in space firing a rocket that does travel in a straight line. Well, with reference to what? The spinning Earth. Oh, okay, it and its atmosphere that's all travelling as one. So you look out at space at this rocket that's travelling straight, and from the ground it seems to curve. That's his example of Earth and atmosphere travelling as one as the non-inertial reference frame, and space being the inertial reference frame. And you've got stuff travelling straight lines in space. That's bollocks. You can achieve Coriolis effect with a roundabout. You don't need to be out in space. It's just his nonsense assertion that defies Coriolis effect. The atmosphere can act as the inertial reference frame. You can demonstrate it with the roundabout. So to assert that same atmosphere is actually tracking with a presupposed ball that spins, meaning that the only way you can have a second reference frame is to travel to space, it's just his made-up story to get around the fact that we don't have any Coriolis deviation. If Earth is spinning and something leaves it, then you see a deviation, like Neil deGrasse Tyson asserts. The problem with that assertion is if you see a deviation from the stands, because Earth rotated under the ball, then it's also rotating under planes, drones, helicopters, hot air balloons. And your flight time from Charlotte to North Carolina, which should take 4 hours on a non-rotating surface, would actually take an hour and a half because the continent, LA's coming towards you. Now, obviously, that doesn't occur, but it would if Earth was rotating underneath. So they assert that we've got Earth and atmosphere bonded together with Velcro. Well, air's unbonded. It's not attached to anything. It's randomly, freely moving in all directions. Definitely not attached to a spinning, rotating reference frame, giving you one singular reference frame. That's just a complete bullshit obfuscation of the actual effect we should observe if Earth is spinning. We should observe Coriolis deviation. That would be things that leave the spinning frame of reference that is an Earth that spins, go in a straight line, and we see them deviating because we're spinning underneath a thing that travels straight. So it seems like it's curving from our vantage point. So you look up at an aeroplane, not attached to the spinning ball, and we go, wow, that plane looks like it's going in a curved path. Well, it isn't. It's actually travelling straight, and Earth's travelling underneath it. But as soon as you say, well, Earth's travelling underneath the plane to make it look like it's going curved, well, then Earth's travelling underneath the plane and your flight times are reduced. And they're not.
It's a train wreck.
Yeah, I agree.
The whole thing is hang on, Mustone. The whole thing is a train wreck because if Earth and atmosphere is traveling as one, you would never even have an argument for Coriolis because you can never experience it. You'd have to be in space to see it.
Exactly. And that's what they
And
then
if any
argue.
of that was actually happening, it would be demonstrable and we would see it every day. We wouldn't even need to talk about it.
Yeah, and because we don't, they argue for why we don't see Coriolis effect, why we don't see apparent deflection of things that leave the spinning Earth, why we don't have reduced flight times. Because once you establish what gives you this apparent deviation, Coriolis effect, and the actual person you're arguing with appreciates and concedes, because they have to concede in this example, that Coriolis effect is an apparent deviation seen from the non-inertial spinning reference frame. And once you've got things deviating because they've left that spinning reference frame, you've got reduced flight times because the Earth's turning underneath the plane. Now, the Earth turning underneath the plane reducing the flight times is not Coriolis effect. That's just a result of Earth turning underneath the plane. But that's what would also give you the deviation you'd observe. That is Coriolis effect. But they then obfuscate this argument by arguing about what Coriolis effect is. It's like, it's simple. To have Coriolis effect, Earth rotates underneath things. That would be balls, planes, helicopters, drones, you if you jump up and down, anything that leaves the spinning reference frame. In the same way, if you've got a spinning roundabout, anything that you throw off it while it's spinning, you'll look at it and it'll seem like it curves away from you because it's left the spinning roundabout. It's really simple. So anything that leaves a spinning Earth is going to seem to curve away from you. Nothing ever does. We don't see Coriolis effect. The only assertions are with things like balls and bullets that have got a fraction of the time in the air that a plane has. So we should see the obvious effect of Earth turning underneath an aeroplane. We don't. So the ground level fundies argue that we've got a conservation of momentum flying in the face of having a Coriolis effect. In other words, we don't see one. We don't see the proof of Earth spinning. It's so similar to the Black Swan defense. We don't see a geometric horizon. Well, you need one. Well, you don't see Coriolis effect. It's all travelling as one reference frame. Earth and atmosphere travel together. But you're supposed to see a Coriolis deviation. That's what you're saying proves Earth spinning. So you go into, well, no, Coriolis is actually from space. No, Coriolis is actually about how you travel northwest, east or south. Well, no, it isn't. It's just spinning reference frame and stuff leaving it.
Yeah, fair enough.
2 housekeeping questions.
Did you
Not
also
bad.
notice?
Go.
Sorry, did you also notice regarding the conservation of momentum? That well, remember there was this old sort of test that was made, I think in the 19th century, with the cannons being fired, cannonballs being fired straight upwards, and then falling basically in the cannon's mouth. And I think what's interesting there is that you wouldn't have that. This proves also the conservation of momentum, because even if there were, I mean, obviously this is begging the question, but even if there were conservation of momentum in the way that they're describing, well, the bullet would have to speed up once it goes further upwards because the speed is higher once you increase the once you're higher up. So
Right.
and it doesn't. So
That's correct.
Yeah, this even disproves within their argument.
Yeah, it's a first
of
law
the
of
conservation of momentum.
correct. To assert that, even though you don't need to get into the weeds of arguing about conservation of momentum, because the argument that they're claiming, their actual claim is Coriolis effect, but you're still correct. To assert that you have a conservation of momentum when you're travelling up on a spinning surface that's spherical, you increase the circumference that the projectile has to travel to track with the x below it. In this case, the cannon example is the x below it on my roundabout example. Well, once it goes up, it's got to travel a greater distance the higher it goes. So it's got to actually violate the first law of thermodynamics and acquire extra energy to do so. So it flies in the face of the first law of thermodynamics to actually assert that this projectile can conserve extra energy as it goes higher. But as I say, you don't need to get into that argument either. As soon as they say, well, no, what's happening is the cannonball's fired, but it's retaining some of the energy that the rotating ball Earth gave it. So it just tracks along with the Earth and then goes back in the cannonball. Well, you go, so you're saying you don't see it deviate? Because the deviation that you were supposed to see in that ball that went up was supposed to prove Earth spins underneath. That's what's supposed to prove Earth spins. This deviation that we would see. Because the cannonball went up and carried on going in a straight line, but we kept moving underneath it. So we saw it seem to curve out of the cannon as it went in the air. That's the thing that's supposed to prove we spin. But their justification for not seeing it is to argue about angular momentum being conserved. It's like, well, no, your proof is that we see a deviation. Your proof is Coriolis effect. Why are we now arguing about whether or not we can violate the first law of thermodynamics when we should just see it deviate if we're spinning, and we don't, so we're not?
Yeah, makes sense.
Anybody from the panel got anything to add?
Yeah, you're totally right. You're totally right. Look, the idea that the Earth is rotating and all the consequences, and taking it a step further, the solar system and how it's supposedly flying through space without leaving any kind of fire trail behind the sun or anything. The whole thing about the motion and the consequences of the motion of the entire heliocentric system is one of the hardest to overcome suspense of disbelief obstacles when you really start to think about it.
Yeah, totally agree. Any more for any more? I'll shout out the super chat. If not,
Nah, go for it, man.
Guns of Navarone RMP. Thank you very much indeed for the super chat. He says, nobody compares to you when it refers to destroying the fundy ball zealotry and the ball. Thumbs up. Well, thank you very much indeed for your support, Guns of Navarone RMP. I really do appreciate it. And with that, I'll say if you are watching this on the Nathan Oakley premiering stream, then stay tuned, as there will be an after show to follow. Unfortunately, if you are watching this live on Nathan Oakley 1980, then this is where we bid you farewell. A huge, massive, enormous thank you to all of you smashed the super chat, liked, commented, shared, subscribed, and all that good stuff. Of course, a massive thank you to today's Discord and G+ panels for making this live show possible. Once again, stay tuned if you're watching on the Nathan Oakley premiering stream, and I'll see you all in the next video.
Oh, what a day! What a lovely day!